In this video, we're going to explore binomial experiments. Binomial experiments are when we have only two options, either we succeed or we fail. So to meet the conditions of being a binomial experiment, we have four specific criteria. First is that every single trial within that experiment is independent of each other trial. So nothing affects one of the other trials that can occur. Number two is that you only have two outcomes. You either succeed or you fail, and that's it. Our random variable is going to count the number of successful trials. And then the last thing is that the probability of success is the same for every single trial. Those are the four criteria we always have to meet. Some basic notation you're going to see throughout. Lowercase n, that's the number of trials that we have. That's our sample size. Lowercase p is the probability for success. Lowercase q is the probability for failure. And x is going to be how many successes we actually had in the number of trials we have. And just remember, because it's a binomial experiment, those two probabilities of success and failure have to add to 1. So if I know one, I automatically know the other because they have to add up to 1. So let's look at an example. We got 68% chance of success with a diet plan, 47 people attempt it, and our random variable is going to count the number of people that are successful. So is this an experiment? Well, each person is going to be independent of one another. We only are measuring success and failure. We're only counting the number of successful people, and each person has the same chance of success. So yes, this would be binomial. In this next one, we've got pennies, nickels, dimes, and quarters, and we select 5 coins without any replacement. Now here's that part that's really important, is those 5 coins without replacement. Because what happens when I pull out a coin, whatever that is, it's going to change the probability of success for each of the other times that I pull the next coin. And because I'm changing my probability for success, this cannot be a binomial experiment. Now as I start to use the binomial probabilities, I have several formulas that can help me with Excel. And Excel is going to be very important to help us with this instead of having to do it all by hand. And these are the 6 formulas that you're going to need to know and just become comfortable and familiar with. You have the idea of when we're looking at an exact number of successes, and the key part there is that this last part is false, and if you look, all the other ones end in true because they're inequalities. So the false gives us an exact, true tells us to count that value and everything below. So it's going to be very important to pay attention to each of these formulas and determine which of these formulas is going to be what I need for my problem. So let's look at an example. We've got a recent study where we have 85% success rate of returning vision to at least 20/40, and we got 6 people having the surgery. We got 2 different problems we're going to look at. One where it's exactly 4 are successful, and the other one where it's at least 4 are successful. And the keywords there are exact and at least. We have the same parts. Number of trials is 6. The number of successes is going to be 4. And our success rate is 85%. The difference is going to be which of the binomial formulas are we going to use. And it all comes down to the exactly and at least. So when we're doing exactly 4, we use the distribution where it's the values as they are with the term false. When we're doing at least, it's 1 minus the distribution, and that we do the 4 minus 1 because when we do the distribution with a true statement, it looks at that value and everything below. If I want to do at least 4, I need to make sure I'm looking at 1 less than that, which would be 3. And then I do true because it'd be 3, 2, 1, and 0. And then I plug those directly into the formula, and I will get my probabilities for those occurring. Now, just like our other ways of finding mean, variance, and standard deviation, we can find that with binomial distributions. Now you can use the discrete probability distribution, mean, variance, and standard deviation, but they simplify to these equations when we have a binomial experiment. And it says that for the mean, it's the number of trials times the probability of success. The variance is the number of trials times probability of success times the probability of failure. The standard deviation, we take the square root. So again, we go back to that problem with the 68% chance of success with 47 people. If we want to find the mean, variance, and standard deviation, we would know that our sample size is 47, probability of success is 68%, which means our probability of failure is 32%. And I can plug these values into each of my formulas. So n times p, my mean would be about 31, almost 32 people would be successful. My variance would come out to about 10 and 23 hundredths. And then my standard deviation, I take the square root of my variance, and it's about 3.2. So what this means is that I would expect about 32 people to be successful with a standard deviation of about 3.2 people.